Well, welcome to this session, the SQL model clause, a gentle introduction. Um, I guess you fell for that one because I'm sorry, that's a lie. There is no easy, gentle introduction into the model clause. Sorry. Okay. Um, I'm Alex. I'm from the Netherlands, so that's why I have this accent. If I'm talking in a way and you cannot understand anything I'm saying, please let me know. Okay. Well, the model clause tends to do that. I'm one of the Oracle ACE directors. I blog, I tweet, wrote a book, and I'm part of the Smart for Apex team as well. Even though I said I'm never going to write a book again, they tricked me into writing another one. So, the model clause. This is what we're going to be talking about today. Theme park, traffic jams, and generating some stuff and some weird stuff as well. Okay. The model clause. It's old technology. This morning I did a session on 12c. It's not a 12c feature. In fact, it was Oracle 10 when model clause were introduced. What year was Oracle 10 released? 2006? 3, actually, 2003. So this model clause, it's 13 years old already. Okay. People tend to shy away from it. Okay. First of all, because it was hidden in the data warehousing guide. Not a lot of people read the data warehousing guide. And that's just like the analytical functions, because they were also hidden in that data warehousing guide. So I really love analytical functions. If you like them too, we can talk about it over beers tonight. The analytical functions, once you get your head around it, they're pretty easy to understand. You can solve very complex stuff with it. With a model clause, not so much. Okay, so the syntax is weird, and you have to get used to that. There are certain use cases for the model clause which are really excellent for them, but it just takes it's a little bit harder to learn. If you have any questions during what I'm saying, she's going to be running around with the microphone to get you to speak up the question, and you get a bear as well. So, how cool is that? Analytical functions. No, not analytical functions. Model clause. So, what is a model clause? You can do. It's a multidimensional array based on a query results. And you can apply formulas to them, calculate new values, do predictions, that kind of stuff. Make forecasts. It's almost like having Excel or numbers in your database. And that's like the use case for it. Like if you extract your data, do all kind of manipulations on it in Excel, then you might be looking at the model clause. All right. Most important part here is the query results, because it only acts on the results that you get back from the database. So it doesn't modify the values in the tables or anything. It just works on the query results. So the hardest part, syntax. Well, hardest part, it's okay. So you have to start with your model keyword. That signals like we're going to be using a model clause. And that's one you really need. The dimension by, you can specify which columns to use for dimension, as well as the measures. You also need the measures. I will explain in more detail what the dimension is, what the measures are. And you also can define rules on them. And those are rules that actually manipulate the query results. And there's a lot more stuff you can put in that model clause. Okay. So for terminology, terminology-wise. So I got this Excel, and the thing you use to identify an individual cell, like these on the outside, like the A and the B's and stuff, and the numbers on the side, those are referenced by as what they call the dimension. Okay, so if you say dimension by like the A's and the numbers, that's how you identify an individual cell. Right? Everybody knows if I'm talking about C3, which cell I'm talking about. Right? Good. C3, yeah. It's there, isn't there? Yeah, okay. So those are the dimensions. Everything in the middle section, those are the measures. Okay, and these measures are the actual values that you're going to be manipulating. you cannot manipulate dimension because that's the way to identify the cell. Yeah? You probably recognize like emp table in there. Like the income column is not in the emp table. Like a grand total at the bottom, that's not on the emp table. These two, like the column and the row on that one, they got there because we specified some rules to manipulate that data. Okay? So the rules are like the spreadsheet functions. Okay, you say, oh, I want to do a summary on these cells, and you get the summary of those cells. So the basic structure is model, dimension by whatever, measures, whatever, and then you have your rules. You have to have all of them in your statement. Okay, you don't need to specify rules, but the keyword and the parentheses need to be there, otherwise it won't compile. So that's optional. What you get returned in your select statement, or what you can query, are basically dimensions and the measures. Okay? So select star will only select what's in the dimension and what's mentioned in the measures. Yeah? So first of all, the dimension. The dimension is like the key of a relational table, or that identification, how you identify the individual cell. Okay? And it must be unique for the result set. No? The measures are the ones that you can actually manipulate. So it could be like a column, like a quantity or whatever. It could be columns from the table. It could be expressions. And what you got to be careful of are these implicit data type conversions. Okay, so this is our first real query that actually executes. So we select from emp, use the model. Our dimension is the emp no, and the measure is a column in a table, like the e-name and the salary. An expression, salary times 1.1. A sysdate, yeah, also expression, and some remarks. So now my question to you is, what data type is that? The last one, the notes column. Varchar. Well, no, it's not. No, it's not a varchar, and it's not a varchar. It's not a varchar 2. It's a char. It's fixed length, and that's the length of it. So if you try to put like something that's really bigger than some remarks, you will get an exception. Data value out of range. Okay, and that's like because you use the expression as a string, it's a fixed length. Okay, so be careful of that one. Now the interesting part, like the dimensions are pretty easy, the measures most of the time as well. Now the rules. And the rules is where all the assignment happens. Yeah, so you have it's an assignment statement. So on the left side, left side, you represent like a cell or a range of cells, could be all of them. On the left side, you put an expression there, or constant, or a bind variable, or other cells, and it could also be an aggregate of cells. Okay, the rules are what makes these model expressions really interesting. Okay, so we'll start with a simple example, which, by the way, is another lie. So select from emp, use the model. The dimension is on the emp no, and the measures e-name, salary, and commission. No rules, so we get all the data. I'm just showing a subset here so people in the back can read as well. So why do we only see emp no, e-name, cell, and commission? What about job or manager? Or see, this is where I see if you were paying attention and not just dozing off, right? Exactly. It's only columns that are mentioned in dimension by and in the measures. Okay, so no job because we didn't mention it. Good. Ooh, well, hang on. I was supposed to do that, wasn't I? Yeah, there you go. Did someone ask a question before? No. Well. Now we're going to add an expression to it. 0 as income. So this one is added as a column as well. Still select star, and that one is selected. And it all have zeros in them, of course, because that's a constant. Yeah? So now we're going to introduce our first rule. And that rule, that one, it reads the measure of income identified by the dimension 7499, yeah, so that's the left side, will be, that's the assignment, the salary or the measure salary identified by the dimension 7499, and add to that the measure commission identified by the dimension 7499. Yeah? So you identify with square blocks, square brackets, you identify a dimension. Yeah? So when you get like 1900 right there. Yeah? Because you add 1600, add to that 300, you get 1900. Yeah? There you have it. Now it would be silly to have like a whole list of rules for each of the employees, because if someone was added to the table or removed from it, you had to modify your query. So you can also use like a more of a wildcard kind of thing and use any as your dimension, which basically means match any of the dimension. Add to that, or the income for that one will be the salary of the current value. So the CV is current value with the parentheses. Add to that the commission of the current value. And the income value, or the income column, all gets values. Yeah, make sense? Good. So why doesn't Smith have an income? Because commission is null. Okay, so it's null. Of course, you can solve this one with an NVL or a coalesce. You can also put it in a model clause. Add to that ignore NAV, ignore not a value. So in that case, it will ignore all nulls in the expression, in all the rules that you're going to define. In that case, it will give you like a full income column. Yeah? Okay. So to make it more interesting, we're going to add more rules to it. We already saw the income one. Now to add like another row to our result set, we're going to say the salary identified by the dimension total is going to be the sum of the salary of any of the dimensions. Okay, so that's how you do an aggregate over a series of cells, series of dimensions. To make this work, because now I'm going to use a char, or at least a string, as a dimension, I also had to modify dimension as well. Okay, first it was an emp no, but that's a number. I had to use a char or varchar. You could also do like a toChar of a emp no, and that could work as well. So with this expression, the salary of the dimension total is going to be the sum of the salaries of any of the dimensions. An extra row is added to the result set. So 14 rows normally in emp. Now you got 15, and there you have the total, which is that dimension, and it's going to get the sum of all the salaries. And did the same for the commission and the same for income. So you can also define rules in a model clause referring to a column which doesn't even exist in the table, but it exists in your result set. Okay, so you can build on top of that as well. And that's how you get the total. Do you really need the model clause for this one? No, not really. You can also get the same results without the model clause. Build it up, all the columns, salary and the commission, coalesce that one. That's the big brother of NVL. For the income column, add group by grouping sets to the complete query, and there you have the same result sets. Yeah? So, quick question, who never heard of grouping sets before? Well, then you learned something today, right? Cool. All right. Questions so far? No? Now you already got a bear, so If you want to get, yeah.
If I, for example, do some arithmetical operation just for these employees, how this wildcard can be?
Okay, so the question is, how do I do the, if I say, well, I want to do calculate for a specific, like employee, in this case, like Alan.
Yeah, well, for specific named employee.
Right, okay. I'm not going to say it depends. First of all, you can use it in the where clause, because that's how you normally filter your data, and then apply the model clause to it. That's the most obvious one. The other one is like you can, in your definition between the square brackets, which dimension you want to manipulate, or which measure you want to manipulate identified by that dimension. You can also put like a case statement in there as well. Okay. You can also use wildcards in there, like all the Allens in this table I want to do this with. If there are more than one Allen, it will always match it. But then you got a problem, because if you have more than one Allen, the dimension will not produce a unique set. So you have to be something else how you identify which Allen, basically. Does that make sense? If you have two Allens, then I'm saying, fire Allen. Who are you going to fire? Both, yeah. Well, that's okay. No, but you have to unique in the dimensions. The dimension, you have to uniquely identify one row. Okay. Sorry, that wasn't intentional.
I want to ask when model clause will start its calculations. It must load the whole result set, or it can do calculation just for a few rows and stream the used rows.
Yeah. So when does the model clause kick in, basically? It will, the model clause will work on the result set, so the result set needs to be present. So it's going to be
whole result set. If it would be millions of rows, it will take very
well,
much
the model clause has like a sweet spot on when to use it. It's not typically not the fastest function that you can execute in the Oracle database, but for certain situations, it's like your only solution that you can use. So it's not the quickest, and it will always be late in executing. So it will work on the result set.
But even if the rules is only in one row, not spread across the rows, it cannot just stream the rows.
Well, if you could reduce your result set from your 2 million table to like the 10 you need, it will be more efficient. Like in your where clause, filter it out early. It will be more efficient than if you first load in everything and then say, "Well, I only want to manipulate this row." You see what I'm saying? Yeah. All right. So like theme park, my theme park example. Like I said, I'm from the Netherlands, and we have a theme park in the Netherlands, which even gets awards and everything. If you ever go to the Netherlands and you have like a family and kids and stuff, Efteling, that's one of the theme parks you want to visit. It's fairy tale themed. It's very fun. Well, that's the commercial break there. What they also have on their website, if you go to visit there, they have like a calendar on their website. And on that calendar, it basically indicates on which days are really busy and which days are really slow. So if you want to go visit and you don't want to stand in line for 2 hours, you should visit on a quiet day. Okay? How do they know all that? They've been open for almost 6 years, I think, 60 years. So they gather all the data of when people are visiting the park. So they know which days, which days are going to be busy and which days are not going to be busy, right? So, but in order to get that calendar up on their website, they need to basically predict, like how busy it's going to be next year. Yeah. So that's what we're going to recreate. I asked for actual data of them, and they wouldn't give it to me. Go figure. So we're going to create a table, theme park visits. Primary key in there for the ID, a visit date, and the number of visitors. Okay. As I don't have the real data, I'm just going to insert some random data for one particular day for the last 5 years. So June 6th, starting with 2010. So this is the data that's actually in the table. on June 6th in 2010, we had 9,000 visitors, in 11, 99, well, a little bit more, dropped again, raised up, yeah? So in order to get this data massaged nicely so we can work with the model class, we want to know how 1 year's data compares to last year's data. Then you can see the difference, right? So, So we use the lag to compare last year's visits with the visits of this year. What's the percentage change this year compared to last year? And now we have all our data ready, massaged, and now we're going to use the model clause. Dimension is by the date. So this time it's going to be a date column. The measures the number of visitors, last year's visitors, and the percentage change between these 2 years. Okay? No rules. So that's easy start. So which columns are we going to show in the result set? Sorry? Exactly, the measures and the visit date. Okay, so we have these columns over there. So the visit date is the dimension, and the rest are the measures. So now we wanted to do like a prediction of, well, like next year. Like say I made this presentation a little while ago. So June 6, 2014, we want to do a prediction for 2015, all right? So we're going to add a rule to it. The number of visits, that's the measure, identified by the dimension June 6, 2015, and it's going to be 0. So if you do that, you get a constant. A row is added to the result set, with the number of visitors being 0, of course. Yeah? The number of visitors of the current year, or of the current value, minus 1 year. So what we want to do basically is look at last year's result set, or results, number of visitors, and basically copy that one down and then manipulate it more. Okay? So the number of visitors of the year that we're interested in is going to be the current value minus an interval of 1 year. So last year's visitors. If you're just going to use that, it's going to copy over the 8866 down to to that new row. Yeah? Now the percentage for the current value of dimension minus 1 year. Yeah? So we just have the 8,000 and a bit value copied over, down one record. And now we're going to take into account that percentage as well. Okay? And if you put everything together, the one we want, the number of visitors from last year, add to that the change in percentage, and then you have like your 8866, add to that 47% increase, and you get your 13,000 something. So this is the thing with that model clause. I'm going back 2 slides. This will give you a headache to figure out what's going on. Let me put it differently. This will give me a headache to figure out what's going on there. Okay? So that's how you get that value over there. Does that make sense? See, no? No? Exactly. So, well, okay, I got burned on this one because someone walked up to me and said, well, statistically it's completely wrong and yada, 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 yada. I know, come on, I write queries. Come on, give me a break there. So basically you're saying this value, well, it's bullshit, excuse me. It's, well, that's not correct because you're taking only into account that 47% change. While years before it dropped and even like, it's ridiculous, right? So what maybe is a better way is basically instead of getting that 47%, get an average percentage on the whole thing. And you can do that too. So instead of getting that percentage from last year, we're going to take the average percentage of any of them, right? And the more data you have, the more accurate it's going to be, right? Well, yeah, okay. We'll have a beer over it and later. Oh, I'll buy you off with a bear instead of a beer. Oh. Eh. So the average percentage on that one, for the one who do the quick math, is 2.7 something, 2.8, and at least we'll give you a more realistic number. Okay. See, but this is the kind of stuff you can do with that model clause. Like, this data is not in the table. It's not stored anywhere, but you can manipulate that result set and make up new values there. Yeah? Questions? Yeah. If he's not watching, yeah, jeez, almost got him.
Functions built in this model clause to work with predictions like these?
Are there any real statistical functions?
Like, so you can do real statistical work.
Yeah. There are a number of statistical functions in there, and they're mainly in the realm of the analytical functions. You can combine the analytical functions or the statistical functions in that domain, like your standard deviation, partition by this, order by that. You can use those in the model clause as well. So not specifically for the model clause, but they are there available to you. Yeah. Do you know that joke about the statistician? The 3 statisticians that went hunting? No. Yes. Okay, yeah, exactly. Yeah. So quickly, so these 3 statisticians, they go hunting and they use a bow and arrow and they see a deer going through the woods. So the first one gets out his arrow and shoots, and he misses like to the left, like 3 meters to the left. So the second one goes. So he shoots 3 meters to the right. So the third one says, okay. Traffic. Don't know about you. Oh, another question over there. Yeah.
Is there a possibility to generate you show the totals
Yes.
in the end, yes? But is there a possibility to generate middle sums, like totals for each department?
Yes, you can do that too. Yes, you can do that too, but there's an immediate button on that one.
Yeah.
Analytical functions excel at that kind of stuff. So in this case, if you want immediate results for like per department or whatever, I would not choose, personally I wouldn't choose for the model clause, but I would go to analytical functions.
Yes, but in model clause you get them in a row, no, like not in the.
Yeah, you can. Sorry. You can. Yeah, true. You can use like the regular roll up for that as well. Yeah. Thank you very much. Yeah. Of course. Okay. So I don't know about Latvia, how bad traffic is. In Holland, it's very bad. This is not a picture from Holland, but from India, but it kind of gives you the idea. So what I wanted to do is like basically see what's going on with the traffic jams. So table with traffic jams, I got a road, a date when the traffic jam was there, and how long it was. So populate this one with 2 roads that we have. The A27, and there's another statement just like it for another road. In this case, as you can see, I used the model clause to generate some data. Yeah? Okay, so we have a whole list of data for 2 different roads, the A27, B52, on a specific date and how long the traffic was, or how long the traffic jam was. Okay. If you want to get an average on the length of the traffic jam, you can just use a regular group by. for a certain date, format it nicely, so we see at least the weekday and how long the average length is. So you get a result like that. So on a Sunday, there was so much, on a Monday, there was that much, and so on and so on. Did you know there's a third argument to the toChar function? You can even put a analyst date in there. So if you have some free time you want to learn Dutch, for instance, you get a list like that. Maandag. Yeah. And yes, you can also put Latvian in there. And there you go. Oh, okay. Oh, okay, we'll skip about that one. So now we're interested in only the Tuesdays because we want to make it like a prediction kind of thing here again. And I'm going to be burned by the statisticians in the room as well. So only for the Tuesdays. That's all the data. Yeah? And we want to do a prediction on when it's going to be on the next Tuesday. So here we filter all the data on the Tuesdays. And we introduce a new one over there. Partition it by road. That one. Yeah? You can do that one similar to the roll-up that we just had. You can also partition it by department and do your stuff with it. So in this case, we're going to partition it by road. So we have two sets or two groups within our result set, which is partitioned by road. The dimension is going to be the date. The measure is going to be the length of the traffic jam. And now we're going to do a prediction of how bad traffic will be on 10th of June 2014. That length on that particular day is going to be the average of the length for all of the dates that we have. And we filtered out on a Tuesday, so it's only going to be the Tuesdays. Yeah? So the partition by is the new kid on the block here. Now the problem starts where you get like a whole set of data, and there's one row added to it, and you have to go figure out which one it is. Right? See there, so there's one row added to the results there, and there's another one added over there. Wouldn't it be nice if there was like a clause in that model clause where you could say, just give me the updated rows? And it's there. So model return updated rows, which will only give you back the rows that are manipulated by the model clause. And then you have like just two rows, one for each road, with the average length in there. So the question is, can you? Okay. So apply the model clause and then filter again. Yes, you can do that. You can. Well, if you can you use the model as a subquery? Yeah, you can. You use a query, put it in an inline view, and manipulate afterwards. Yes, you can. What I was getting here at was like, this is only the Tuesdays, right? But there are more days in the week. There seems to be a Tuesday missing. This one? No, that's fine. Okay. Well, it's slides, right? It's slideware, so could be manipulated any kind of way. Yeah. So these are only the Tuesdays, but there are more days in the week, right? Like Monday and stuff. Oh, bless you. So we could write a query like this. Change the dimension to the date as well as the day of the week. So Monday, Tuesday, whatever. And then I want to see it for this day on a Monday, and what's the average length of all the Mondays, and so on and so on. But you see there's a lot of repetition going on there, right? So the dimension is on the date as well as the day of the week. Okay? And there's a whole chunk of gathering all the data for a week's worth. Okay? So this is the pattern that we kind of identify. The date, weekday, the average length for any of the dates, as long as it's a Monday. Yeah? And it will generate the data, because we only want to return the updated rows, so we get like 14 rows back. wouldn't it be nicer if you could use like this information? This generates a week, right? Sysdate plus 7 plus row number minus 1. Get like next week's dates. If we could use this data in our model clause. Like if you work with spreadsheets, you can have multiple sheets in there, and you can reference one sheet in a different sheet. You can do stuff like that in the model clause as well. Okay, so we can reference this weekdays queries in our, so that's the worksheets, in our main results. And those are the keywords that you need to use. The references and the main results. Basically, the whole query stays the same. We're going to iterate our rule 7 times because we have 7 days in the week. And the rule is going to be, well, this is a tricky one. The length of the traffic jam that we want is going to be next week's date based on the iteration number, because we iterate our rule 7 times, plus 1. And it's going to be the next week's day as well as the day as well. Okay, so we're going to take next week's actual dates as well as it's a Monday, Tuesday, whatever. That's that one. And that jam length identified by that is going to be the average of the length of any date as long as it's the same day as the one that we're referencing in our dimension. Who's got a headache already? Yeah, good. So here we're going to reference that worksheet, and it was called weekdays. That's how we reference it. And that's the iteration number because we iterate the rule 7 times. So the complete query is going to be something like that. We reference the weekdays, you put your dimensions, going to have its own dimensions, your main result over there. Okay, and you get, of course, you get the same results. Okay, 12 minutes to go. Good. Model clause is always a nice topic over beer, so yeah. So you can also generate rows with it, or you can generate stuff. Select from dual. Dual only has one. Dimension is row number. We cast our null as a number. Iterate 7 times. The R identified by the iteration number is going to be the iteration number, and you get like a short list of 7 numbers, 0 to 6. Yeah. If you can generate rows like that, you can also, generate like a dates a week on the same principle. See, all dates. Or if you take it, do it differently, and use it as a CHR65 plus your iteration number, and iterate 26 times, you get the alphabet. Right? So I have a 15-year-old son, and he hates math in school. So he asked his teacher, well, math is useless. That's what he told his teacher. And his teacher said, well, no, it's not. He said, well, if you look at the alphabet, and you spell math, you get like M is 13, and the A is 1, and the T is 20, and the H is 8. What does that add up to? Exactly, 42, which is a reference to the Hitchhiker's Guide to the Galaxy. The answer to life, the universe, and everything, math. Yeah. Talking about math, Fibonacci, 0, 0, well, there you go. You get the Fibonacci sequence as well. So that's about generating stuff with a model clause. Pretty fun. There's also some real funky things you can do. I didn't come up with all these examples, so don't hold me accountable. You know what this is, right? It's a fractal, right? And if you're if you have too much time on your hands, you can write a query using that model clause, which is about 42 lines of code, and you can generate your own fractal in SQL+. Pretty cool. A former colleague of mine, he was really into Sudokus, and he also used, one of his things was he solved the Sudoku with a model clause as well. So we have a variable S, which holds 81 characters. Here's a complete Sudoku. in there, 81 characters. The model clause in there, and just a mere 100 rows of coding, and there's your solution for your Sudoku. He also wrote a couple of different ones to solve Sudokus with collections and stuff, and recursive subquery factoring. The model clause is I think the slowest one of them. So if you want to solve Sudokus, don't use the model clause, but at least, well, you can, right? Okay. So that almost wraps up everything. So my thoughts on the thing, the final thoughts. So is it worth getting out of bed for that model clause? That's an actual dress, by the way, by Victor and Rolf. So I think so, yes. But there are certain use cases. Okay. See, the telltale sign that I normally use when I want to go to the model clause is if it's easier to get the data, put it in an Excel sheet, and then manipulate it. That's like one of those telltale signs that a model clause might be beneficial. Okay. And of course, it's a lot more efficient if you do it in SQL than if you have to export it to Excel, manipulate, and so on and so on. So I think, yes, it's worth getting out of bed for, but there are certain use cases for it. So does the model clause get easier over time? I would say no, because the syntax is kind of hard. And as you can see, it gets complex really quickly. Okay, very powerful, but kind of hard. You can have a really elegant query with it's just a single statement, but could be quite large. But it's so hard to debug those kind of statements. So, will it give you a headache if you're working on them? Yeah, absolutely. But they got pills for that, so that's too easy. So, one final thingy. Match recognize. If you were in my talk this morning on 12C, I also mentioned match recognize. It's really awesome stuff. You can do pattern recognition with it. And I got this example, it's new in 12C. I got this example from Stu Ashton, so all credits go to him. He had this problem where he had a lot of data with different study sites and number of people attending, I think. And he wanted to divide it into groups as long as the total count didn't exceed 65,000. So if you do a quick calculation, you can see that there are 3 groups over there. And so he wanted to group by all of them. And you want to get the results out like that. So the first site, 1001, runs to 1022 and get the total count. So that was the objective. So first time, or not first time, first using the model clause, you could solve this puzzle. But as you can see, it gets quite tricky over there. Yeah. Also, the analytical functions are in there as well. Row number to do the calculation. And it gets a result set. Using the match recognize clause, line 3, it's a lot simpler. Okay. The definition, the pattern that we're looking for is as many as A's as you can, and A is the sum of the count as long as less than 65,000. And it's going to show you the first site, the last site, as well as the total sum. And of course, it gets the same results as well. Okay, so match recognize, interesting stuff. Learn about it. So I showed you comparison to Excel, talked about theme park, traffic jams, generator, as well as some funky stuff you can do with it. Learn about that match recognize, especially if you go into 12. I'm sorry I lied. The images that I used weren't mine, but credits go to all of them. And we still have some almost 5 minutes left for some questions. So let me open up the floor. Yes. what does this do for performance? Performance-wise, the model clause doesn't. It's not the most performant function out there. If you can solve it in any other way, using your regular aggregates, your group bys, roll-ups, grouping sets, whatever, analytical functions, by all means use those. If all else fails, you can also use the model clause. It will do the job. It's always faster than exporting all your data to Excel, with all the Excel limitations as well. So yeah, so it's not the fastest kid on the block, but it does the job in SQL without resorting to PL SQL. Yeah? All right. Oh, one more.
Instead of joins.
Well, no.
ETL
Hang on.
loading, for example.
Stop right there. If you want to use this instead of joins, no, hell no. You should just regular join would be outperform everything. But if you, so the question is, how do I reference the reference part of it? You use as a dot notation. So the reference worksheet that you define has a name.
But algorithm, it is uses something like hash join, hash function.
Oh, okay. Well,
what is uses inside?
No, it doesn't use a hash join. I don't know, actually. It works on the result set, so it's past the execution phase of your query. So how you would query the data?
It must define the key in the reference. So
No, but
what algorithm it uses?
No, it doesn't use it that way. It works like it gets the data from tables, and it uses an execution plan on that one. And on the result set, it manipulates it, but it doesn't use like a hash join or anything like that.
But it should use some algorithm to get from reference correct
Yeah,
line.
but that's all in memory stuff.
In memory, but what algorithm?
Jeez. I don't know. I didn't. Yeah. I don't know. Yes, of course.
Would you suggest to use it in conjunction with dynamic SQL?
Would I use it in conjunction with dynamic SQL? Okay, I'll answer it. Like, would I use dynamic SQL? Let me start with that part first, all right? If I can avoid dynamic SQL, there was Mario. If I can avoid dynamic SQL, in all cases, I would. If there's no reason to use dynamic SQL, I would always shy away from it, because you always need a hard parse on dynamic SQL. Okay. So would I use dynamic SQL with the model clause? Shush. If the model clause doesn't give you a headache, then the combination with dynamic would surely give you a. So in short, no. Yeah. Well, what about SQL injection? Yeah. So that's a whole topic. That's a whole different topic altogether. With static SQL, Mm-hmm. Yeah, if you're going to build dynamic SQL, you're always vulnerable to, for instance, SQL injection. Well, and even with bind variables, I would tend to shy away from it as well. Yeah, gets more tricky as well. So I think time's up. 24 seconds. So, thank you very much.